Hey all, in this series of videos and blog posts I've been looking at the Ruby basics, starting with variables. Again, just to reiterate that we really need to understand the different types of variables in order to know how to assign and reference and modify, etc., the data that we're using. One of the variables that we can also use is a bit strange in that it's named constant, and as you've guessed, it's meant to be a constant value. It's meant to hold and reference a constant value, or be assigned a constant value, I guess is more correct. So it gets referred to under the variables, and people occasionally misuse this as a variable, but having looked at the different types of variables, the instance and class and the global and all the others, we know that we can make this part of the set that we'll use, but we need to use it in the correct way. So the main aspect to remember about constants in Ruby is that their values are meant to be set. So when they're initialized and then remain constant for as long as the script remains held in memory. The Ruby interpreter doesn't actually enforce this, and we'll prove that when we have a look at this little line of code here. But it will throw an error, so obviously it's considered bad practice to start changing around values that you've assigned to a constant. In the previous post about Ruby global variables, I perhaps suggested that they could be used to hold a constant value while the script was running, and that's the case. I mean, if you declare a value to a variable, if you assign a value to a variable and then don't change it, well, it's constant in a way, right? But it's not actually a constant. I think it was the hero name that we assigned a value to as a global variable in our little game example, a code example. And the idea was that you would declare the hero name and it would be constant throughout the life of the program. But it was a global variable because there was a potential to change it. Maybe later on they acquire some kind of title and they get called, Mr. Superhero or something. So you would want to change it. Even though it was meant to be globally available throughout the game, it's not a constant proper. Now, let's have a look at this little piece of code that I've put up here. So what we're doing here is declaring two constants, and you can tell there's obviously a convention here of using uppercase and assigning it a value. So we've got the first constant of 10, the second constant of 20, and then we're just going to put to the screen the value of the first constant is, and then substitution of whatever the value of first constant is, and then second constant. Now, okay, so let's just see what I put here. Now we'll change the value. Okay, so what we should strictly do, of course, is assign a value to a constant and not change it. But down here we're going to change first constant to 30 and then print it out. Let's see what happens when we call this little script. And again, all we're trying to do with this script is see what happens if we try to change the value of a constant. So this one is called assign. I can't spell. Assign, reassign. Yes, this looks like the one. Okay. So if we can see this on screen, value of the first constant is 10. Yep. Second is 20. Okay. Now we'll change the value of the first constant. All right. And then some warning. As I've said, what Ruby does, it comes back and complains. It says, we've already initialized the constant first constant. Previous definition of first constant was here. Value of the first constant has been changed to 30. So we can see Ruby has allowed us to make the change, but it's complained. And as I said, therefore this is bad practice, right? Okay, there's another little error we should look at as well, and let me just pull up a quick little Ruby here, and this is that if you try to use an uninitialized constant, you should get the name error exception thrown. So let's just do a very simple one of what hurts uninitialized. My God, I can't spell tonight. Uninitialized constant. Okay, and then we will go and declare an empty constant. So let's just save this down as let's put it in there. We'll call this don't do this dot rb. Okay, and then in here, let's clear the screen. Uninitialized constant, and here is the name error. So we can't just have a constant that isn't assigned a value and just leave it there. Sorry, and then attempt to use it. Okay. So let's skip back to looking at the use of constants. So we've seen a couple of errors, changing it, using it when it's not been initialized with a value. But let's see what we should be doing. So constants need to begin with an uppercase letter. So it could be, inventory, for example. And on the previous post about instance and class variables, you'll remember. Let's have a look. Let me just pull this one out. That the class is declared with an uppercase letter. Interesting. And you probably realise from that naming convention that every class and module name creates a constant. Let me just close this one so I don't get confused about where I am. However, module class names are usually written in camel case, so it could be something like, new class name here, for example, camel case, or intercapping, I've heard it called. So to help differentiate between, is that a class name, when I use it later on, or I use it, I start calling it, adding values, etc. It's either, the convention is either to do it all uppercase, or where needed, put an underscore in between. So if we're looking at our script, and we've got this plus a bunch of other variables being declared, some global variables, etc. When we look at this, we'll know this isn't just some regular variable. Firstly, because we'll know that it's got an uppercase letter at the start, so we'll know it's a constant. But then the fact that it is a constant, this is not a class name, is because it's written in all uppercase letters. Okay, now scope of constants. As with our local, global, instance and class variables, there are some scope rules to bear in mind when using constants within Ruby scripts. One of those that I've seen used quite a few times in things like Selenium automation scripts, for example, is that the mistake is that constants can't be defined in methods. Depending on what tool you use, it can appear that it's working, but in fact there is yet another error that gets thrown, which is a dynamic assignment error, and we'll have a quick play with that in a second. And constants defined in the main body of the script, a bit like this, can be accessed globally. So if I then had some other constructs, some classes, some modules, some methods, I could get access to them. So if they're declared in the main body of the script, their scope is global. But constants defined within a class or a module can only be accessed within those classes or modules. So let's have a look here. In fact, I'm prattling on, I forgot I had a good example here. So if we declare a constant in the main body of the script, it's accessible globally. But if we declare a constant in a class or a code block, its scope is that code block. Okay, so why don't we have a run of this? Well, so what we've got is this constant, mob inventory. Creature's inventory is empty right now, it says. This should be global then. And then the mob's weapon, and it's just a bit of text, mob's weapon is a club, should only be available within the class, right? So if we, and I'm sure you remember this class from the, remember class and instance variables video that we've just put up. So let's have a look here. Let's see what's going on. Pretty straightforward. Initialize the name, so we get the name. Here it is. Okay, and exactly the same as we did before. This line is no different. And we're saying here that we want the inventory to be substituted for whatever the value of mob inventory constant is, which is global. Okay, so it should be global. If we can reach it from within this code block, it must be global. And then the mob weapon, and this is, well, it's got a local scope within this block, and we'll print another line that uses this substitution of mob weapon. Okay, we've got mob type, which comes from the class variable. We've got the instance variable here, so you can see we're starting to pull together these different kind of variables. That's pretty good. And if we scroll down, so we have a little value that says call from the main body, so mob inventory. So this line attempts to call the mob inventory constant from, in fact, let's just close that off. So we call this mob inventory constant from outside of this code block from the main area. Okay, so access the mob inventory constant via the class. So mob OR1, what is inventory? So we pull inventory, and in theory it should put called from the mob inventory. And then we'll try and call the mob weapon that's defined in the class itself. So it shouldn't be global, so we shouldn't be able to access it outside this code block. So if we get here, we should see some kind of error, right? But we should be able to get to inventory, because inventory is outside the code block. And in this way, we can check that this is global, because it can be called from within here. It's been declared outside of a code block, but it can be reached. But then when a constant is declared inside a code block this time, we shouldn't be able to reach it. Okay, so let's have a look at that. What we got? Accessing constants 001. Let's see what that does. What am I doing? Okay, go into here. Hopefully these examples are straightforward. Don't forget, you can always always hit the blog and go and read about this as well. Take your time to look over these examples, which is called what? Accessing constants. Okay, so let's see what we've got. Call from the main body. The creature's inventory is empty right now. Okay, so call from the main body, mob inventory. Right, creature's inventory is empty right now. So that line seems to have worked. Call from within the class. The creature's inventory is empty right now. Okay, so called from within the class, mob inventory. So we've called this method, and this has reached back out to the inventory. Good, okay, so we've proved that that is obviously global. We can call it from outside the code block and from inside the code block. And then we go to mob weapon, called from and defined within the class. The mob's weapon is a club, so we can call the weapon that was defined in the class. Very good. Okay, so we get the idea of being able to reach into, obviously using the appropriate methods here on the class, both the mob weapon that's inside the class and the mob inventory that's outside the class. And obviously we can reach these methods within the class itself. Okay, so guess the final test would be then to define a define a constant inside a method. And that's what this does. So here we are, we have a constant inside a method. And if we try and call it, then we should see a problem. Okay, so let's save that down. Go back to our little working box over here, and let's call this method now, and let's see what happens. What's this one called? Constant defined in method. Okay, it doesn't like it, and it doesn't like it because it's saying there's a dynamic constant assignment. A dynamic constant assignment. And what's happening here, of course, we're running the script, we're assigning a value, but we are dynamically assigning it every time we call this method. And Ruby says that isn't the idea. You're not supposed to be dynamically assigning something every time you call it. It's fixed. So that's the little evidence of the fact that you can't, well, I mean you can write it, but you clearly should not be trying to define a constant in a piece of code that is variable in its own scope of actions. Right, so this is quite long, quite a bit to take in, but you think about it. Constants defined, uppercase letter, but generally to distinguish them against classes we use all uppercase, underscores if needed. We assign a value once and that value doesn't get changed. We don't start doing things like this. You can change it, and there is another method that we'll cover later on where you can kind of legally change it, but you really shouldn't. You know, it's bad practice. You've got other kinds of variables, local, global, etc., that probably would do a better job here. Accessing constants, we've seen that we can access constants in different ways. If it's outside of a code block, it's global. If it's inside of a code block, it's local to that code block. And in the case of a class, obviously we can call methods from the class and reach both outside of the class and inside of the class and access those values. Don't put constants inside methods. Again, your interpreter, etc., the tool you're using might make it appear that that's working, but you don't want to do this. And don't declare empty constants or you'll get an uninitialized constant error. Okay, so initialize them with a value, don't change it. I think that's pretty simple. I mean, that's what it boils down to, right? Alrighty, so as always, I'll put these scripts up under cyreath.co.uk/blog download. There'll be a link in the blog post. So enjoy, comment, and in the next video we'll look at arrays, and we'll move on now from looking at the individual variable types with their scope and the different categories, holding a single value, and move into arrays where we can start to hold multiple values and how we access those and use those when we've got more than just, you know, a single simple value that we might be holding. Alright, thanks for watching.